The next question concerned the image of an object with a diverging lens. Now, first thing, we have the equation 1 over f equals 1 over I plus 1 over object distance. I abbreviate that OB because down here I'm going to have to compare O with 0, and it's going to be difficult to do that with the two symbols looking the same. Okay, so I've used OB for the object distance. Your text uses a different notation. I don't remember exactly how they notate it, but it has the same meaning. Okay, now you're given that the object has a height of 1.59 meters. You have a diverging lens. The image forms at 3.18 meters, and I believe the focal distance is given as 1.6 meters. Okay, so you have, and I wrote this down wrong. The object distance is unknown. I wrote down the 1.59 meters because I was thinking about things rather than looking at what I had. Okay, so we've got to get rid of that. Okay, so focal distance, I say, is negative 1.6 meters. Image distance, negative 3.18 meters. Now, why are these negative? Well, we have a sign convention, and you need to review that in your textbook. The paradigm example of an image formation is the real image formation by a converging lens. And if we follow the three main principal rays, they converge at a point here, which creates the image. We have the focal distance, the distance behind the lens through which rays parallel to the axis converge. And we have the object distance, the distance of the object from the lens. Now, each of these is going to be measured from the lens. So I've got an arrow from the position of the lens to the position of the object, an arrow from the position of the lens to the position of the focal point, and an arrow from the position of the lens to the position of the image. In this case, all these are positive. O, F, and I are all positive. Okay? If they go in the opposite direction, then if one of these or more goes in an opposite direction, the ones that go in the opposite direction are negative. So we have, in this case, with the diverging lens, well, if the object is here, here's your object distance. If your focal point is here, here's your focal distance, and that's going to be negative because it's going in the direction opposite what you have here. And then the image forms on this side of the lens, not on this side. Nothing converges over here. You don't have anything converging to form an image. The convergence is virtual along the lines of these rays. The point where these rays intersect is going to be the focal point. Okay, and you have a third principal ray. You have the ray parallel, which passes through, at least virtually, the focal point. You have the ray through the center, which is not, which maintains its direction, doesn't change direction. And you also have another ray, and that would be the ray that comes out of here parallel to the axis. And that ray turns out to be the ray that would start here and be aimed at this point. Now, it's aimed at this point, but it hits the lens and it comes out parallel to the axis. And that ray would also pass through this point. And something about what I just said doesn't seem quite right with that last ray. But anyhow, the first two rays, not gonna take time to puzzle that out. The first two rays do converge and form an image here. Okay, so there's your picture of the diverging lens. Okay, what I was saying here, I might as well finish saying it since I just figured out what I'd said wrong. If this ray is aimed at this focal point, then it comes out of the lens parallel to the axis. And if we extend that back here, that also intersects these two rays at the tip of the arrow, which would be the image of the tip of the arrow. Okay, well, I started to say that wrong. I couldn't figure out what I'd done wrong, but I did something there. Okay. In any case, we see now why this focal distance and this image distance are both negative. Now, if I come up here and try to draw a figure similar to this one, for an object that's just inside the focal distance, well, I have this ray, which comes along here, and we've already seen that, and I have the central ray, and they can intersect here, so the image has to be here. Well, the image distance given in the problem is 3.18 meters, which is greater than the 1.6 meter object distance. Okay, that can't be because of this. We can't have an image out here behind the object. So the image has to be in here, can't be out here. So the picture shows us that, and the equation is going to confirm that. The equation confirms that because if we put these numbers into the equation, we get 1 over f equals 1 over I plus 1 over object distance. We have 1 over negative 1.6 meters here. That's going to be a negative number. Now we have 1 over the object distance. We know the object distance is positive because the object is on the object side of the lens. And then 1 over the image distance is 1 over negative 3.18 meters. That's going to be a negative number. This negative number is going to be smaller in magnitude than this negative number. So if we want to calculate the object distance, first thing we would do would be to add this quantity to both sides. This quantity being of smaller magnitude than this quantity, we get a smaller result over here, but still a negative result. Okay, adding a smaller negative quantity to a bigger negative quantity, we still end up with a negative quantity. Adding a smaller quantity to a negative quantity of larger magnitude gives us a negative result. You can convince yourself in lots of ways that adding this quantity to both sides is going to give you a negative, which would mean that the object distance would have to be negative, and that's not possible. So the equation tells us that it's not possible, and the picture tells us that it's not possible, and the two reconcile. This incidentally also addresses the problem of the question Richard asked, where we had the question of drawing a picture, pretty close to this picture actually, where the object of the image forms at twice the focal distance. Well, this picture fits that pretty well. The object distance will then be equal to the image distance. And we can explain that by the equation and so forth. But that's not the point. He then turned it around and said, well, what if it was a diverging lens? And I said, well, then the image would have to form at twice the distance of the object, which is about what happens here. And this is why it couldn't happen, and this is why I couldn't draw it, and it was at the end of class, so we just had to end on that note. I couldn't draw it, and then we see that we could confirm that with the equation. It's not possible.